just wrap up for 6.1. I know that some of you are not here. Then we'll figure it out. Either you guys can watch the recording, right, or come to me during office hour. I'm sure that'll help you to catch up, pretty quickly. But like I said, for the rest of the class, you expect, a lot shorter lesson. So that's why I want to quickly get to, the key point. And I was thinking about something else until Noah, right, reminded me. So Noah, is it okay if I share your concern with the whole class? Yeah. Okay. All right. So now, let me freeze the screen. All right. So I want you, if you're looking at a packet right now, please go to page 222. All right. So that's the question 1C. All right. So as you can see that the version that they worked out is, pretty straightforward, right? Not much you have to do. You guys now realize factoring out something, right? Even though it could be not as straightforward as just a single factor or a number, right? But Noah was asking me, like, what to do for the version on the right hand side. And of course, you can see right away that the secant x can be factored out, right? But then still, it's no way you can see that the left hand side is gonna somehow turn to the right hand side, since you have I think that's probably better to put down once you factored out the secant. All right, so let's say the left hand side is secant, right? 1 minus sine squared x, right? So now, see that if I want to get into the cosine x, I don't see it on the left-hand side. Not to mention that I have something that's just way much different from the cosine x. So at this time, I want you to take a look at the reference sheet. All right, everyone, you have one, right? So take a look at the bottom two slides, especially the tips or techniques that they numbered from 1 to 5, right? So what did they say in number 1, technique number 1? Rewrite the more complicated side, right? We did, right? We're trying to do that in terms of sine and cosine. So now, do you see that you didn't have to do that for this question since everything was in sine and cosine? But here, and I guess that if you forgot about doing it, you probably get lost, since, how do I turn that secant into cosine? Well, then you think about, oh yeah, we could have done it in the first place, right? But now, would you rather factor the secant, then you turn it into 1 over cosine, or would you do it right away?
Would you do it before?
Right. So, would it make a difference? Or at least that maybe, let's see what happens if I do before, right? So I'll write the left-hand side as you guys know, secant is 1 over cosine, right? So the first term is 1 over cosine minus 1 over cosine, and then you have the sine square. So honestly, I don't have any preference towards either, but you guys tell me which one you think it would be better for you to factor out the common factor if you have to do it anyway. Is this better than that one? Now, okay. Now, the only concern I have is, when people see, 1 over cosine or the sum factor on the denominator, right? It's not as often as you see sometimes things on the numerator, right? Now, if that's not a big deal for you to still factor out 1 over cosine, it's fine, right? But my point is, the reason why that you guys can get lost sometimes is because that you probably haven't turned things into the things that you're more used to. Right? And now, what if I have tangent on the right-hand side? What if I have cosecant on the right-hand side? Right? But do you see that it's the same logic? It's hard to match things when things are not in a consistent way, right? It's like, I guess that maybe this could be analogy, if it's not good, then we'll think about something else. So you guys like to play Legos, or the Lego sets, the advanced ones, right? Let's say I like to have the over 1,000 pieces or a couple thousand pieces, the technical, things, right? So let's say build the Mercedes, like a Jeep kind of thing, Jeep wagon, right? You know that they're pretty hard, since you kind of have to imagine the manual is like a 3D, right? And also all the pieces, sometimes they go on top of the other, or they will have to like shift a little bit, right? And if you got one part wrong, you're probably not going to realize until like 10, 20 pages later, right? So what I normally do is, I'm glad that they put different bags, right? So I open the first bag, and I even sort the pieces into different colors or even similar shapes. I don't have to do shapes, but I definitely put them in different colors, right? So why would I do that? When I look at my manual, and it says that, oh, go get a little circle piece, right? And I see that, oh, it's a black circle. Then I go to all those piles. I'm not looking at the circles right now, right? I'm looking at the black pieces. I'm going to find out the circle. Now, the reason why I do that, maybe it's just me. When things are similar in a certain way, it's easier for you to sort them, organize them, right? Or even to match them. Because how would you know that what they like? Sometimes you know that they have a little scale on the bottom, right? If you have a like a stick that has to be this long, but they might have different kind of sticks, right? So you have to match it, right? But sometimes you might have sticks in different colors, right? And what I hate about Legos is the colors sometimes are so similar, especially the advanced pieces, right? You can tell, is that a light gray or dark gray, right? Anyway, so now my point is the technique number one says that turn everything into sine and cosine. This is like when I have all kinds of shapes and colors of Lego pieces, I put them in, let's say, color black and color red. So I can easily find out what I want, or at least I have an idea what to do. This is probably what you should think about doing. Okay. Now, well, since we started this question, and I guess that if you go with the first version, then you would have turned it into 1 over cosine, right? 1 minus sine square x, right? So now, what do you do next? If your goal is to turn the left-hand side into the right-hand side, but the right-hand side reads cosine x. Well, my goal is to have cosine x. Well, this guy's cosine. At least I'm not, I don't have a big problem with it, right? But I definitely don't like the sine square, right? That makes sense? You want cosine. So now the question becomes, is there a way you can turn sine, especially sine square, into cosine? Or something to do with the cosine? Now, for those who are not here in the past days, so think about this. There are so many identities, right? And so far, the fundamental ones that you saw on the cheat sheet, but turns out that you're going to have a lot more. I'll say that one of those is probably one of the most frequently used identity. And it turns out to be the first version of the Pythagorean identity. Okay, so that's why I said to the class yesterday, whenever you see sine, not to mention sine square, I want you to think about cosine square. I want you to think about that identity, sine square plus cosine square equal to 1. Right, and vice versa. If you see cosine square or cosine, think about, sine square. Therefore, remember that our goal is to turn everything into cosine because it looks like, the right-hand side, I see sine square, right? So look at the identity, sine square plus cosine square to 1, isn't 1 minus sine square nothing but cosine square? You take that, you divide by cosine, you get cosine, right? So now I'm glad that after 2 classes, Noah reminded us that we could still get lost, even as early as the first or the second step. And the reason could be that still you're not that experienced, in doing this kind of algebra. But you know that it's still basic algebra. But when you're not doing things to x squared, right? A plus b, or the kind of a polynomial, right? Everything seems complicated superficially because they're hidden behind the sine and cosine stuff, right? Not to mention you have things worse than sine and cosine.
That makes sense.
So now this is why I seriously urge everyone to spend some time, not right now, to go over those techniques, right, on the reference sheet. You could also find it on the textbook, right? They have some general suggestions. Start from, what? Let me show you what that is. All right. Here, full screen. All right. So they say make sure that you start from the more complicated side, right? And also always thinking about whenever and as early as you can to use some fundamental identities. And by fundamental identities, I mean the ones that I'm giving you on the top of the cheat sheet. Okay. And also you have 5 general tips and techniques, right? We'll see about number 5 because I think that it's not my favorite. But the first 4, number 1 says write the complicated side in terms of sine and cosine. Do that if you don't see those guys and you see tangent, cotangent, secant, cosecant. We write them in terms of sine and cosine, right? And always think about factor whenever you see a common factor. Okay, it might not be just a factor of 2. It could be a sine of x, right? Cosecant, whatever. Now number 3 and 4 are not that fun to play with, right? You have to deal with fractions, especially number 4, combining fractions, right? You see that they didn't even bother to get you some formula because it's not a simple process you can use a formula to get to deal with, right? But I mean, at least that you need to be aware of. If you're looking at fractions, right? A single fraction with multiple numerators, split them. Not to mention that if you have multiple fractions added up or subtract, then combine them, right? But unfortunately, that you have to do the least common denominator to be able to combine fractions. Okay. So simply put, if you get lost anywhere, like say doing a test, right, or come by, do the quiz, think about that. Hey, can I do one of those, right, from 1 to 4, or did I start from the more complicated side, or did I have everything in terms of sine and cosine, right? Once you check off these things, I'm sure that most likely you'll figure it out. Okay? And this is now, let's see, what I'm trying to do. Oh yeah, and the reason why I was showing you before I, went to discuss this problem was something that I want to go over today, and that's the reason why I think that lesson will be a lot shorter than normal. So let me ask everyone to take a look at the question number 2 on the last page of the packet, which is also projected on the screen. So they worked out this question on the left, right? They want you to work on a similar question. Let's just go over it, together. But make sure you understand what they're asking you to do. They say, show the following 2 expressions are equivalent. Okay, so one of them is log, natural log, right, of the absolute value of tangent x and the other one is log of the absolute value of a sine plus log of absolute value of a secant, right? And they are equivalent, or simply put, I want to show that they are equal. Right? Show, verify, right? They're pretty much the same thing. So I guess that almost everyone, see that something just kind of disturbing, right? That's the natural log. Let's mention absolute value. But then you realize, okay, if we're still trying to verify some identities, you start from the more complicated side, right? In this case, if you say log of absolute value of tangent x is the left-hand side, I'll say that the right-hand side might be a little bit more complicated, right? So I suggest that you start from the right-hand side. And also, do you see that they have tangent and secant, right? So I hope that I will turn them into sine and cosine, right? So if you do that, let's say if you're looking at the right-hand side, they say, look, they have two logs adding up, right? That must be one of those that you still remember back in college algebra, right? You can turn the sum of two logs, the same base, of course, right, into anyway, for some reason that they decided to go with the left-hand side. Right, this is the right-hand side, right? So if you decide to go with what we call it, the product rule, right, for the logs, so you could combine the two logs by writing natural log of absolute value, right, of the product, sine of x times secant of x. Right? And it turns out that this is the only thing that they're giving you the log, because they're trying to ask you to combine the two logs by multiplying the sine and secant, but they make it, kind of a, fancy, right? But now at this point, I hope that you realize that there's still something that we haven't done, right? Which could have done, as soon as we can, that is to turn the secant into 1 over cosine, right? So now if you keep writing, this is nothing but natural log sine of x times 1 over cosine x, right? And then what do? Well, you see, this combination of sine and cosine, and they're in a ratio form. So I hope that you can recall from one of those identity, right? So quotient identity. So sine divided by cosine does turn it into tangent, right? And then all of a sudden you realize that, oh, it's nothing but the left-hand side. Oops, my bad. All right, does it make sense? So, I mean, hopefully you see that the logs are there only for, preventing from realizing you could have done the multiplication right away, right? Because, somehow that, it might be a little bit odd, right? You end up multiplying the secant and the sine, even though that they weren't multiplying in the first place, right? And that's the only reason that they threw the logs, so that you don't see it right away, okay? But now, of course, if you said why we had to start from the more complicated side, right? I mean, you don't have to. If you feel like that, just because you read from left to right, you can start from left-hand side, right? And that's exactly what they did, and it still works out, right? It's like, if you know how that's supposed to work out, you know that you can try your own way, right? Or sometimes to brutally force it to work. But let me ask you, what are odds if you do have something like this and you have something on the right-hand side which is way more complicated than what's going on? Is it possible that you go from a simple thing and develop a whole world? It's possible, but it's very hard, right? Again, the simple logic is you're given a bag of flour and asking you to make a dessert or any kind of a pastry. I mean, you could do it, let's say I don't allow you to have any kind of a, other things. Maybe you have to figure out a way to maybe just add some water, right? Rub it and fry it, whatever, right? But the thing is, what if I said, hey, you have, the whole grocery store, right? Just want you to pick whatever you need to make a simple pastry, to make it as simple as you can. Okay. So I'll say that you're better off to start from a more complicated side, but you're not obligated to do so. Okay. Anyway, so one more challenge with the logs, right? And I'm sure that you definitely see that having the logs is not really that big of a deal because it is still those trick stuff, right? Not to mention the algebra that you guys might still have, to get used to, right? Now, any questions about this anymore? If I move on. Okay, so if you're good, let me get to this question here. And I'll ask you to at least think about what you could do for maybe a minute, right? Say, plan ahead. I was telling the student yesterday in third period, I said, so for problems like that, or in the future that if it's not something that you see right away, you still try to picture yourself 3 steps ahead. So let's say, can you think about what you're going to do in the first, second, and third step and see where you're going? And hopefully you can tell that is that the right direction. Okay. And it won't hurt if you do that. Yeah. Yes. Yeah. And again, just to make sure that they're asking to show these two guys are the same, right? They're equal. So it's an identity. Negative log, absolute secant plus tangent, equal to log, absolute secant minus tangent. Right? So just think about for a minute, then we'll work it out together. Right, you have an idea? Go ahead. Okay, good. That's one of the property. So it's like contracting that negative sign, right? And put it on top of whatever is inside the log. And that's taking this guy into the -1 power. That's just reciprocal, right? Yeah, that's something that we'll do. Could be step number 1. And also if, since Ryan's looking at the left-hand side, I mean, even though it's kind of a far-fetching, but left-hand side seems a bit more complicated. Maybe it's for the negative sign, maybe because it ends up being putting this guy on a denominator, right? But I guess that the right-hand side is not better, or any better. Yes, definitely, we'll do that. We'll do something about a negative sign. But what are the first things that, or name one important thing, or the thing that the most important thing that you want to do, if you don't know, like, what to do about negative sign, what will be the first thing that you better do? Okay, that's actually the first tip, right? It might make it worse, at least that for the first, 1 or 2 steps. Trust me, hang there, it will get better, right? So let's do this, okay? So I'm just going to start from the left-hand side. Right. And it's negative natural log, right? Now, instead of putting the secant, I'll put 1 over cosine, okay? Tangent, what is that? Sine over cosine, right? Okay, so now, what should we do next? Just be reasonable. Based on the tips and techniques I already told you. 1 over cosine plus sine over cosine add them, right? So two fractions, right? Why not? Not to mention, hey, they have the same denominator, right? You don't have to figure out anything new. Why wouldn't you do that? So it will be 1 plus sine of x over cosine of x, right? So I guess that now you're kind of stuck, right? There's not much you can do anymore. And this is probably when, hopefully, you remember back in college algebra, like Ryan says, that you could contract that negative sign onto the power of the argument here, right? So let me write it as log of 1 plus sine of x over cosine of x, right? Absolute value entirely raised to the -1 power. Okay. As you know that the -1 power is the reciprocal, right? But how do I write the reciprocal of absolute value? If it's absolute value of a fraction. Yeah, Adriana? No. Well, it's surprisingly easier than you thought. Now, think about if that makes sense that you just swap in the numerator and denominator as you normally do. As if that the absolute doesn't care about the reciprocal. No.
If it was
Good. Yeah. If there's a square, if it's a negative. But yeah, look close. I'm glad that you start to think about, and you actually will do it, and maybe just in a minute. Right. So now, seriously, we're stuck. Right? There's no way I can do anything more about that. Well, guess what? Here's a more advanced technique or strategy is, you trying to make sure that the two sides are equal. Sometimes you force the left-hand side to go one step at a time into the right-hand side, right? But maybe, hey, let them compromise a little bit, right? So let them meet somewhere in the middle, right? Instead of asking, your friend to always meet you at your house, right? Go to his house, or maybe somewhere, in between the houses, right? So now let's take a look at what will be, what's going on the right-hand side, right? And you know what? Because I'm going to end up doing something on the left-hand side as well later. So let me write down the right-hand side on this, right here. The right-hand side, well, again, let's do the same thing. How about that? Just be consistent. If I've been doing that to the left-hand side, changing the secant and tangent into cosine and sine stuff, I'll do that as well, right? This is 1 over cosine x minus tangent, which is sine over cosine, right? And now I see, I have a good reason, right, to combine. Oh, sorry, my bad. Missing the log. Bear with me. There we go. Yeah, we have the natural log. Don't forget that. Okay, so we subtract the fraction, right, by subtracting the numerator, 1 minus sine over cosine. All right, so now let's take a close look at those guys. I'm going to make them look the same. They look similar, but they're way different from each other. So this guy has cosine on the numerator. This guy has cosine on the denominator. This guy has 1 plus sign here. This guy has at a different place, but 1 minus sign. Again, I'll let you think for just a brief moment. Your tools are those fundamental identities, right? And the things that we normally do is just only algebra. And algebra involves multiply, divide, right? But I'll say that most likely multiply stuff, right? Instead of dividing it. But what else did I say? Like maybe 10 minutes ago, like when you see sine, you're thinking about cosine, right? Not to mention, like Akeem or Noah mentioned that I still want to turn this guy 1 plus sine or 1 minus sine into cosine. But you're not able to do that unless you have what? Square of sine and cosine, right? But I don't have those. How am I going to be able to do it? And here's a little trick. So you guys seriously need to remember, And that usually works out together with the Pythagorean identity. So now you pick a side, whichever, because I don't see any difference between the two sides anymore. So let's say if you still want to get back to the left-hand side and say, let me multiply the numerator and the denominator with something for no reason. Right? So what we're going to multiply is the conjugate of the denominator. Okay? I'll let you, again, think about for a brief moment, why am I doing it? Okay. So let me highlight this part. Okay. Anyone figure out like why it's so unreasonable, right? Okay, anyway, so expand or FOIL, right? Or distribute, however you want to call it. But don't touch the top. All right, so the bottom, 1 plus something times 1 minus something. Isn't that just 1 square minus sine square, right? On the top, let's keep it as is. Cosine times 1 minus sine. Okay, keep writing. So what is 1 minus sine square? According to the Pythagorean identity, it's nothing but cosine square, right? And this is why I said that better not to distribute a cosine on the top. If you do that, you're going to be factored out again, right? So now, can we cancel the cosine? Just square the cosine on the bottom, right? So cancel out one factor. You're looking at log, right? On the top is 1 minus sine, right? And bottom is cosine, and that turns out to be exactly the same as the right-hand side, right? So now, again, that's, let me zoom all the way out.
And we could have done that to the right side.
You could do that as well, yeah. So no, and I suggest that you try after class. So think about what if you decide to stop at this moment and you go to the right hand side, do something similar, not exactly the same, but similar in the same fashion, and turn it into the left hand side, right? So now what did you learn from this problem, or anything new you learned? Well, you know what? It's good that you know that where you tend to get stuck, right? And now focus on how you resolved it, right? How you figure it out. And it turns out that it's the same logic, but not that straightforward anymore. Because I said, because you're thinking about how I'm going to turn 1 plus sine into cosine. Because you saw the cosine, you want a sine, right? And now I'm telling you, this is a way to do it. You haven't seen it before, now you do. And it's called multiplying the conjugate, right? And we've utilized the difference of squares, right? And why do we need the difference of squares? Because we have squares in the Pythagorean identity, right? We have the difference of squares. 1 minus sine square is cosine square. 1 minus cosine square is sine square, right? But yeah. So my last comment will be about one other technique on the cheat sheet or the reference sheet. So now let's take a look at number 5, see what it's trying to tell us. They say, hey, for some reason, you know, you might want to think about multiplying a numerator and a denominator by a binomial factor that appears on the other side of the identity. You might say, well, what they're talking about. And this is actually what we did over here. we multiply the numerator and denominator by a binomial factor, which is 2 terms, right? That appears on the right-hand side. So I don't know what to say about this, technique, because I think that it's pretty much useless, to be honest. Yeah. And you know what? It's even worse than useless because it might be misleading, right? So I want you to understand the logic behind why we decide to do this. Instead of thinking about, hey, don't ask me why. If you see a binomial on the other side, right, go multiply the top and the bottom of the other side with the same factor. But your question will be, when do I do that? Do I do that every time? No, because that's like 1 out of 100, situation that you have to do. So you better understand what will be the general strategy behind why you decide to do it. And now, so this guy who wrote the book is a professor at Miami-Dade Community College. So I think that he's making a ton of money just by writing the textbook. And this is the 7th or 8th edition. And you know that every time they had a new edition, they get to make more money, right? The book is getting thicker, right? The paper quality is getting better, right? And they do minimal changes on the problems. And now it turns out that this is something that this guy added to this newest edition. I've never seen it from any prior editions, right? For no reason. I mean, the only thing that you have to play with the log is, well, in this case, somewhere here, right? Not to mention that there wasn't a tip number 5. Now he added it. He said that for some reason, right? I don't know why, I don't know when, you're gonna have to do something like that, right? So I don't think that's not a right way to teach you guys the skills.